Good afternoon. So my name is Ashok. I'm from the exotic land of South India called Karnataka, the land of spices and Bollywood dances. Yeah. So I'm here to talk about writing apps for Wear OS. So before I start going forward, a little bit of about myself. I'm not going to bore you all. I'm a Udacity mentor. I'm a Udacity project reviewer. I'm a YouTuber. I have written 2 books, one of them on Android Wear projects. It's from Pact Publishers. And I'm a photographer and a storyteller. So I have authored 2 books. Mastering Firebase for Android development. Okay, so why am I here? So I'm here to rewire our brain to think of writing a Wear companion apps. If we have an existing Android mobile application, how can we extend of having a Wear application? And also, understanding Wear application development and the best practices and anti-patterns. So why Wear apps? So the countermeasures for drop-offs is not just testing or not just having retuning your mobile app. Having a good companion Wear app will also increase the mobile application usage based on your notifications and all this. And Wear OS is getting very powerful. Wear device hardwares are getting very powerful. So this small, tiny little device is packed with 512 megabytes of RAM and 4 gigabytes of storage and 1.3 gigahertz of processor and 300 mAh of battery, which is almost like if you get back to a decade back, that was the configuration of my personal computer. And that's in my wrist right now. So yeah, by writing Wear apps, we will have easy access on all the notifications, which is one way to reach out to all your customers. And also, Wear OS, after Wear 2.0, allows developers to write standalone applications, which is a very exciting feature. And the only possibility, not just in mobile apps, it's only possible is writing fitness-related application is through a Wear device. And watch face development through new complications APIs and other important things. So do you all have a Wear device? How many of you are having Wear device? Sweet. Have you guys tried developing Android Wear apps? Oh, awesome. Was it on Wear 2.0 or 1.5x? 2.0? 1.5? All right, cool. So if we go back in time, Wear 1.5 was released in 2014 March. That was targeting to the platform Jelly Bean 4.3 and 4.4 KitKat and later. But it had a lot of gotchas. The recent analysis says 720,000 Android Wear smartwatches were shipped as of the date, March 15, 2018. So the gotchas of Wear 1.x was there was no battery efficiency. And there was a lot of issue over the network layer. The Bluetooth had a lot of pairing issues. And also, the complex user experience of 1.x. And a limited scope for developers. So here comes the new Wear, which is Wear 2.0. It had a lot of revamped UI with material design and darker colors and more circular user interfaces for round watches. And also standalone apps, Google Play Store. We have a Google Play Store officially in wearables right now. So we don't have to go to mobile phone to install Wear apps to phone, to our wearables. And built-in keyboard, handwriting recognition, stackable notifications, smarter notifications, and so there are dialer manufacturers with the radio in it, inbuilt. So Google also thought to unify the name to Wear OS. So they upgraded from Wear 2.0 to Wear OS this March. They rebranded it. And there are a couple of good practices, which is design and development guidelines. So our Wear OS or Wear apps should be timely. The information that we display in the Wear 1.5-inch screen on timely basis. It should not be a lot of asynchronous calls. We should not do it. And we should make sure the user interface is glanceable and easy to tap. And also time saving. User don't have the time. So that is one of the reasons that we should think of writing wearable apps. So the couple of building blocks of Wear application. So we can define the custom layouts, how we define it in our mobile development practices. At the same time, we can also make use of exclusive wearable user interfaces like Wear navigation drawer, wearable actions, watch view stub, and wearable recycler view, and showing confirmations, and multi-function buttons. So in Wear, not just one button, which is home button, there will be other hardware keys that is called multi-function button that we can tune it or customize it to a specific action that we have. So to define our Wear user interface, the two layouts that we have is box inset layout and curved inset layout. So the box inset layout identifies the form factor on its own. It is a form factor aware frame layout. So what it does, if it is a square watch dialer, it identifies this is a square dialer. If it is a round dialer, it identifies the application in round dialer. And a curved layout. So I don't know this 1.5 inches visible from here. So if you see, there is a curved layout. This is called rotary input. You might have seen in Wear 2.0. That is another layout that we can use to build Wear apps. So in earlier, we had a list view equivalent to wearable. That is called wearable list view. That was for Wear 1.x. So later we upgraded with recycler view, and we are calling that as wearable recycler view. Just that, add the wearable key before the recycler view. And this wearable recycler view is optimized for wearables. It understands the RAM efficiency, memory efficiency, and everything. And it works very well in the wearable devices. And to show some progress, we have circular progress layout. You might have seen, if you are a Wear user, you will see the timer, and it will show you what is happening in the Wear device. And so this is how we we will connect that XML layout to our activity, and then we will instantiate the callbacks of circular progress layout, and we can do the intended action in it. So we also have a UI component to exit the full screen activity. Since it's a 1.5-inch screen, we should make sure there is no lot of actions users are doing. So we should make sure on a swipe, it should be easily swipeable. But on a horizontal scroll, it is a little difficult. Say suppose map application, while you are scrolling the activity, the map will scroll. So what happens, if once the loaded map ends, then it will scroll. So this is how the exiting full screen activity happens on the map-based variables. So this is swipe, dismiss, frame layout that we just saw. And where navigations. So to cut down all the actions that variable had. So earlier in 1.5 or 1.x, we had a grid pager, which had too much of paginations to perform one action. Users have to go through all the tiles to perform one action. But that has been eradicated, and we have very straightforward approaches like navigation drawer and action drawers. These components are directly similar to our material design navigation drawers in the mobile app and the action drawer. So the navigation drawer component comes with the package address android.support.variable.view.drawer variable navigation drawer. So just remember that people get confused with the old supported deprecated variable navigation. So I'll show you. So there are some deprecated classes for variables and alternative and replacement. So action chooser view is no more supported. So if you're even thinking to write a companion app for variables, please consider going through this deprecated classes, because this will stop not to do a mistake. Action chooser view is replaced by alert dialog, which is a normal alert dialog in the mobile, Android mobile platform. And action label is replaced with variable action drawer view and a confirmation overlay. And box inset layout is replaced with box inset layout, but the package address is a different one. So if you look at the URL, it is a widget. So that box inset layout is a little different than the other box inset layout. And the box inset layout params also widget-based box inset layout. So all of these classes have its equivalent alternatives. So if you are using variable navigations, so the navigation drawer would look like this if it is a multi-page navigation drawer. If it is a single-page navigation drawer, it would look, all the menu items would look in the same page. And actions. Actions is another component which enables you to quickly respond to a particular action. Say suppose you have received a message, and you will get this action sheet, which can help you to reply quickly, or reply with the text message, or add photo, or with the location. All your Wear devices comes with a GPS hardware, most of them. So you can share your location and perform the intended action. So as I was saying, this is not a multifunction button, the physical button you have, but the different manufacturers comes with 3 to 4 buttons if you have seen. Like the Fossil watch with the Wear 2.0 has 3 buttons. So these buttons are called multifunction buttons. So in addition to the power button, Android Wear supports another button called multifunction button on the device. The variable support library provides API to determine the multifunction buttons included by the manufacturer. So the rotary input method. So the rotary input method enables you to have the rotary input. So this is how it looks. You can give a click events and you can perform a specific action. You can start an app and all that. So the common Wear UI components, as I was mentioning, watch view stub, wearable recycler view, box inset layout, delayed confirmation view, navigation drawer, and action drawer. So Wear 2.0 comes with IMF, Input Method Framework, which has IME, which is Android Input Method Editor by default from the operating system itself. If you have a edit text as a component, you are free to use the keyboard, which pops out automatically. And it has the swipe gesture and all the voice-based input and everything, quick chips that allows you to choose quick replies. Wrist gestures. So if you are a Wear user, you might have seen when you rotate your wrist towards your face, the watch activates the dialer. So that is one wrist gesture. So we can program these wrist gestures based on these key events. So there are wrist out, and the key event is called key code navigate next, and description, the key code goes to the next item. And wrist in, the key code goes to the previous. Maybe you can have a gallery. You can change your images just like switching the keys. Or you can use your Wear to control a presentation. And best practices for wrist gestures: review the key event and key event callbacks, and make sure you have the parallel gesture for the every wrist gestures that you are using. What I mean is, say suppose you're using a wrist gesture to have a next image, then please have a visual or a view component to perform the same action. And do not interpret a repeated flick gestures into your own new gesture. It may conflict with the system shaking the wrist gestures. Use request focus and clear focus carefully. So that will allow you to restart the gesture events. Okay, so one of the things which actually matters most is seamless data communication over this 1.5 inches screen. So Wear OS by Google, a watch can communicate with a network directly. So this watch can directly connect to Wi-Fi. If it has a radio, which means a SIM card, we can put a SIM card and subscribe to our 3G or 4G network, and we can use the data in it. Without even actually a companion phone, maybe iPhone or Android. So how the data communication happens? So the data is segregated into a couple of data items or elements, which are the data item, the asset, the message, and channel client. The channel client takes care of identifying the node. The node could be, so this can be node if my watch is trying to connect to this phone. And data client. Data client is going to be my Wear app. So the data client will connect to my channel client, and it will establish a communication. And wearable listener service, which enables my Wear app to connect to my phone. So this is some graphical representation that actually shows how Wear 2.0 can directly connect to Wi-Fi. So at the first time, we need to have our mobile connection, and then we need to have our watch to be paired with our phone. First, we need to add our Wi-Fi via phone once, and then later we are free to use it directly from the Wear. So the wearable listener service is directly extending to service, which is Android system component, and implementing a couple of interfaces, which are data API interface, message API interface, and capability APIs, and channel listener API interfaces. So if we are migrating our app, our mobile app, or the existing wearable app to Google API, there are some deprecated components, and there are some replacement components to it. So the deprecated components to capability API is a different package address of capability API. The capability API has a capability client, and the channel has a replacement called channel client.channel. And the channel API has channel client. Data API has data client. Message API has a replacement called message client. So if I want to connect my Wear app to my phone, I need to advertise the capability that my Wear has. So to launch an activity on handheld device from wearable device, I use message API class to send the request. Multiple variables can be associated with the handheld Android device. My Bluetooth can be connected to my Android. My Bluetooth speaker can be connected to my Android. And my car Bluetooth also can be connected to my Android phone, and also the wearable device. So the wearable application needs to determine that an associated node is fit to launch the activity from the handheld device to advertise the capability of the handheld application. So what are the capability that this Wear has? For example, it has a PPG sensor to sense my pulse rate. It has step counter and a lot of other capabilities. So this device advertises all these capabilities to my Android phone. So how do we advertise the capability? We need to write a configuration file in the XML folder in the resource directory. We need to write the capability tag in the where.xml file, or you can name it however you want. Define the capabilities that the device provides. For example, if I want to use the voice capability or microphone capability of the Wear device, I need to define that in the where.xml like this. And then I'm free to use the voice transcription. So retrieve the nodes with the required capability. So initially, we can detect the capable nodes by the capability.api.getCapability method. But let's comprehend how to manually retrieve the results of reachable nodes with the transcription capability. So we need to write a method using a class called capability.api, a capability API, which is directly a class of wearable class. And it provides a method called getCapability, which includes a method and return callbacks, which accepts Google API client. And that will take care of connecting our capability of the watch to phone. To detect the capable nodes as they connect to wearable device, we need to register the capability API to Google API client. The following example shows the register the listener and retrieve the result of reachable nodes with the voice transcription capability. So once the connection establishes with the voice transcription, my capability gets registered to the phone. Okay, so a small heads up here. On of the chance that you create a service that extends to wearable listener service to identify capability changes, you might need to override a method called onConnectedNodes. So this method will listen the filtered connectivity details. For example, when a wearable device changes from Wi-Fi connection to Bluetooth connection with the handset and other data-related connection, it will have the information in the data layer events. Okay, so it happens to be, I have an app called Strava. Strava is a fitness app. I have installed directly from the Wear Play Store. But I also have a mobile app, which I have not installed in my mobile phone. So how will I enable my user to install the mobile app? So if I directly install a Wear app using Capability API, I can ask my user to install a mobile phone app through Play Store availability class. So it has a method called get Play Store availability on phone. If that returns a valid which is true or false. If it is true, then we can think that that is an Android phone, if Play Store exists. If it returns a false, then it has to be an iPhone phone. I mean iPhone. So then we can start our the equivalent iTunes app, or the iPhone app, or the equivalent Android app from the intent call. The standalone applications, which is the greatest feature of Wear 2.0 and the Wear OS. So we can have our Wear OS to have a standalone application. We don't need a Wear companion. Whereas in Wear 1.5 or 1.x, it was mandatory that we need to have a companion app. But now it's not anymore. We can write 3 kinds of application, which is completely dependent application, semi-dependent, and completely independent application. So the completely independent applications are called standalone application. So it can work like any other mobile phone application. So these are completely independent of the phone app, semi-independent, and dependent on the phone app. To make a Wear app completely independent or semi-independent, we have a metadata tag that we need to use in our manifest file. So it has a class path called com.google.android.wearable.standalone. If we make this class path to true, then it is a standalone app. So there is another warning. So regardless of the possibility that the value is false, the watch application can be installed before the corresponding phone application is installed. In this way, if a watch application identifies that a companion phone does not have a necessary phone application, the application ought to incite the user to install the phone application. Okay, so watch face. Okay, that's definitely not that. So watch face is another artwork. This is not just a normal watch face that we have seen. So the idea of having a Wear companion is it dictates our style. If I'm wearing a blue color dress today, I can change my watch face to a blue color watch face. I can create a blue color watch face with some of the complications included in it. So how do we do it? We use watch face service class and watch face service engine methods. So watch face controls. So usually watch face will have 3 controls, which are hour stroke, minute stroke, and second tick stroke. So using this, we can compose an analog clock. So we can also write a digital clock in the similar fashion with the simple text views and other components. Maybe we can have a self-customized view that shows a timer. So we have a couple of common issues in writing watch face. So we have different form factors. We need to address all of this form factor issue when we are considering writing a mobile Wear watch face. And our watch face should be battery efficiency should be high. So when we write a watch face, we think too much of animations will make user to install the Wear watch face, but that will result in a lot of problem. It will consume a lot of battery. Since the display of this small device is AMOLED, if we produce a lot of colors in it, it will dry the battery. It will drain the battery. So that's why we recommend to use dark theme. And too much of animations is also a problem. And the kind of assets we use inside Wear app, that will also be a problem. Watch face, depending on any hardware, maybe on an accelerometer, that will also be a problem. So we need to make sure all these dependent parameters will not affect anything relating to our watch face. So watch face also includes a complications API. So the complications API is old artwork. It is not new. It might sound new, but our traditional watchmakers, if you notice, they'll have a hour handle separately and a minute hand separately. They'll have a small magneto navigator inside the watch, inside the face. These are the complications that our watchmakers used to have in back those days, in 1800s. So this is exactly the same expression and the same ideology, but we are using our smartwatch to have complications. So here we can have our agenda from my calendar. I can also have different complications in my watch face. I can post my day-to-day weather report on from my watch face, complications to watch face. So what exactly complications is? It is nothing but a data provider. So complication data can be anything. So that has nothing to do with the watch face. The complication data provides the data to watch face. The Android operating system requests the data to complication, and data provider requests the data, and it will display in the watch face. So watch face will not have the access directly to the data provider. So there are important methods when we are using complications API to consider. One is on complication activated. This callback method is called when complication is activated. On complication is deactivated. This callback method is called when complication is deactivated. On complication update, this callback is called when the complication has some updated information. So in earlier, on Wear 1.5, if we want to distribute the Wear app, we were supposed to bundle the Wear app inside the mobile APK. But post Wear 2.0, that is not a thing. We can generate a signed Wear app directly, and we can publish it like the way we publish our Android apps. We visit the console, and we give the title and description and store listing, and we choose the category where, and we will distribute our Wear apps. So any questions? I'm mostly done with my...
First of you, thank you. A warm hand, please.
All right.
Are there any questions?